Hello, today we're going to talk about the Cartesian coordinate system, also known as the rectangular coordinate system. Most of us are very familiar with this. Cartesian coordinate system is made up of two number lines. Like so. We call the horizontal x-axis, the vertical the y-axis. Again, just to be clear, that's the vertical. This is the horizontal. In the center, we put a little O or 0. This is called the origin. And from the origin, if we count to the right, we count in a positive manner. So 1, 2, 3, 4. From the origin, if we count up, we also count in a positive manner. So 1, 2, 3, 4, and so on. Now, if you go left or down, you're going in a negative manner. So -1, -2, -3, -4, down 1, 2, down -1, -2, -3, -4. Now, on the x, y axis or rectangular coordinate system or a Cartesian coordinate system, I mentioned briefly, it's Cartesian. Cartesian is named after a man named René Descartes. It's from France. The rectangular coordinate system is actually descriptive of how points interact with the x and y axis. So, points probably better referred to as ordered pairs. Looks like x, then y. X shows left to right movement. The y shows up and down movement. So we'll briefly look at some point, I don't know, +2, +3. We're going to do this. You're basically going to say to yourself, okay, starting here at the origin, since this is +2, at x value of +2 or x coordinate, I'll move in the positive direction on the x-axis. So you move to here. And then 3 says, I'm going to go up or down on the y-axis. So we'll move to here. So up to 3. Now that point is if you draw horizontal and vertical lines out here from your two endpoints of this line there. My point is actually this point here, called point 2, 3. And this is called a rectangular coordinate system because what do you get right here? Right here, you get a nice fancy rectangle. So all you're going to do is move out on your x-axis distance 2, then go up or down, and move out on your y-axis, in this case up 3, and you go left to right until these two lines, this line value here and here, will intersect. A lot of times when you do that, for example, we do, I don't know, -2, say +2, you come out here, 1, 2, right there, then you go up 2, so you go up 1, 1, 2, and you're just going to draw your point right there. Call it -2, 2. So let's graph some more points. Actually, before I graph more points, one other thing I want to mention about this. If you look at your X and Y axis, the X and Y axis breaks your page up into four spaces. So we call those quadrants. This is here we call quadrant. Quadrant 1. This would be, we're going to abbreviate quadrant, not just Q. Quadrant 2, quadrant 3, quadrant 4. In algebra, the idea of quadrants doesn't come up too often, but every once in a while that'll be brought up. In trigonometry and calculus, the idea of quadrants is very important. All right. So graph, or sometimes this is referred to as plotting. So graph or plot the points. So point A, point 2, 3. B is the point 4, 0. C, 1 minus 3, and then D, minus 6, 5. Now when I'm graphing X and Y axis to do a lot of stuff on, when I write out my scale, I could write 1, 2, 3, 4 there. I'm just going to put a 4 here. And since I count it 1, 2, 3, 4, I know the scale here is 1. You could write every letter out. If you do that though, or every spot out, you can create a colored graph. So to avoid that, I usually go out by 4s or 2s. So A23 says, come out to the left, 1, 2, so right there, and we'll go up, 1, 2, 3, right here, and where these match up, that's the point A. Now the point 4, 0, right, X is 4, so I'm going to go out to the right, 4, and since the Y value is 0, I'm not going to go up, I'm not going to go down. So I just go out 1, 2, 3, 4, 1, 2, 3, 4, there we are, that's B. C. C is positive 1, so I'm going right, and Y is minus 3, so I'm going to go down. So I'm going to go right 1 to here, down 1, 2, 3. That's C. Finally, D. That's supposed to be minus 6, minus 5 right there. So minus 6, minus 5 means I'm going to go, the minus 6 is left 6, and minus 5 is down 5. So left 1, 2, 3, 4, 5, 6. So this is how far we're going. Then we're going to go down. 1, 2, 3, 4, 5, 6, we'll say. And this is the point D. All right. The next thing we want to talk about is equations in 2 variables. Examples are y equals mx plus b, 3x plus y equals 7, y equals x squared plus 5x plus 5x plus 3, x squared plus y squared, 17. These are all examples of this. And the solutions for equations in two variables are points. Because I have x and y, solution sets are made up of points. In fact, a graph of an equation is all the points that satisfy the equation. And satisfying the equation, aka solutions. So when you're graphing an equation, you're looking at all the solutions of a graph in a graphical form. So look at an example here. Graph 6x minus 4y equals 12. This is an example from your book or a problem from your book, and they give you a table. Sometimes it's referred to an XYT table. This is your X, your Y, and then the cross there is your T. And this one, they gave us very specific values. They gave us 0, X, a 0 for Y, a 3 for X, and 3 for Y, which means I need to go in and fill in this value, this value, this value, and this value right here. So all we need to do, right, if X is 0, right, for X is 0, I'm going to take this 0, and I'm going to plug it in to this equation. So 6 times 0 minus 4y equals 12. 0 minus 4y equals 12. Minus 4 times y is multiplication, so I'm going to divide by minus 4. Y equals minus 3. So there we are, minus 3. On our next row, we're given y equals 0. Now, is it possible to kind of do this in your head sometimes? Yeah, it's possible to do it in your head. It's possible to do this very much more in depth or less in depth. So, kind of depends on how comfortable you are. So, 6x. I'm going to show the longer version. Times 4y, and y is 0, equals 12. 6x equals 12, because that whole thing right there is a 0. To get 6 by itself, I'm going to divide by 6. X equals 2. So now I have the point 0 minus 3 and 2, 0. I guess we have 2 more points to do. X equals 3. 6 times 3 minus 4y equals 18. No, equals 12. 18 minus 4y equals 12. I'm going to get y by itself, so minus 18. Minus 4y equals minus 6. Divide both sides by minus 4. Y equals positive 3 over 2 after you reduce it. And the last one, for y equals to 3. So you get 6x minus 4 times 3 equals 12. 6x minus 12 equals 12. Add 12 to both sides. Scroll up a bit. 6x equals 24. Divided by 6, x equals 4. So there we are. Move it around a little bit. Now I need to graph this table. So each line on the table is a point. So the point, right, this is the point 0 minus 3, this is the point 2, 0, point 3, 3/2, and the point 4, 3. Make a table here, or sorry, a graph, 1, 2, 3, 4, 1, 2, 3, 4. We have the point 0 minus 3. Oops. So 0 minus 3 puts us at 0. I'm not going left or right. I'm going to go down. 1, 2, 3. 2, 0 says I'm going to go right, but not up or down. So 1, 2. 3, 3/2. 3/2 is 1.5. That helps you guys. So I'm going to go 3 to the right, up 1.5. So 1, 2, 3, up 1.5. So about there roughly. And finally, x is 4, y is 3. So here's 4, up 1, 2, 3. That's kind of what your picture is going to look like. Okay. Let's look at one more example. This one's a little bit bigger. So the table they give us this time, 0, 1, 1, 2, minus 3. So again, I need to fill in all those spots. We're going to do it the same way. If for y equals 0, you have equation 0 equals x squared plus 2x plus 1. Since the degree of this equation is 2, or has a highest power of 2, I have to factor. The factors are plus 1, or 1 and 1, and they add to 2. So this is going to break into x plus 1, x plus 1. Now, they're both the exact same factor, so I'm only going to set 1 equals 0. Solving it, x equals minus 1. And we're just going to keep doing it. For x equals 1, using the equation, y equals, again, if I wasn't clear, I'm taking these values here and plugging into the corresponding spots in the equation. So I have 1 squared plus 2 times 1 plus 1. Or 1 plus 2 plus 1, y is 4. The next one, for y equal 1. So I have 1 equals x squared plus 2x plus 1. Now I need to solve this again. If I want to try a factor, a quadratic, that means we need to make this here needs to be 0. So minus 1, if 0 equals x squared plus 2x. Now if I have two terms, either you want to use a special formula or you look for the GCF. In our case, x squared and 2x share x in common. So factoring it out, I have x plus 2. So either x is 0 or x plus 2 equals 0. So right here, I have an answer of x is 0 and x is minus 2. So you actually have 2 points. So you have 0, 0, or minus 2. So this here is going to work out to giving you the point 0, 1 and the point minus 2, 1. So because I got two x values right here, gives me 2 points. And then the last two, let x equal 2, let x equal 3. And my equation, y equals 2 squared plus 2 times 2 plus 1. 4 plus 4 plus 1. Y equals 9. Finding the last one. Go back to my equation. Y equals x squared plus 2x plus 1. So y equals 3 squared plus 2 times 3 plus 1. 9 plus 6 plus 1. 16. So 9, 16. Then let's move over here and draw our graph. So 1, 2, 3, 4. 1, 2, 3, 4. And up 1, 2, 3, 4. 1, 2, 3, 4. All right, let's plot some points. The first point is minus 1, 0. So I'm going to go left and not go up or down. So minus 1, 0 is right here. 1, 4. So I'm going to go right 1, up 1, 2, 1, 2, 3, 4. Then I have either 0, 1 or minus 2, 1. So 0, 1, right here. Minus 2, up 1's right here. And then when x is 2, y is 9. So x is 2, y is, here's 8 and 9. So something like right there. At minus 3, I did that wrong. I apologize. We need to fix that. So this is wrong. At minus 3, let's just erase that, I guess. Y equals minus 3. This is minus 3 squared plus 2 times minus 3 plus 1. or y equals 9 minus 6 plus 1. Well, 10 minus 6 is 4. So this should be a 4. I apologize for that mistake. So at minus 3, we should be up here at 1, 2, 3, 4. Now, this equation here, y equals x squared plus 2x plus 1, it's a polynomial. Polynomials are smooth. So you want to try it look full and smooth. So do your best when you come down here to this point. Don't make it a sharp one. It needs to be a rounded curve. And the curve should bow out all the way. You graph it. It's hard to do that sometimes freehand, but that's how it should work. Okay, there it is. Let me know if there are any questions.